All right, everybody, we are going to be working on limiting reactants here today. So the question was, why would we need to know what the limiting reactant is for a reaction? Well, we did a reaction yesterday with baking soda and vinegar, and we should have seen that in flasks 4 and 5 that we had some baking soda that was left over. That was a visual that we saw. So it does say here that usually we have more of one reactant than we need to completely use up the other reactant. So in this case, in that example that we actually had baking soda was our excess reactant, meaning there was too much of it. So we actually saw it was left over. On the other hand, in those same 2 flasks, we ended up using up all of the vinegar. And we know that we used up all the vinegar because we didn't see any more bubbles happening. So we know that that was all used. So when we have a situation like that, we call that the limiting reactant. So it stops or it limits how much of a product that we actually get because it runs out. So in flask 4 and 5, we didn't have any vinegar left over. It all reacted. And we, like I said, we know that because the baking soda was not reacting anymore. So there was nothing else there to react with. All right, so let's look at, so chemists, why did we want to know this? Because chemists work with moles. So if we know how many moles of one substance we have, or how many moles of each of my reactants that I have, I can predict how many moles of my product I'm going to end up getting, because remember, chemists work with moles of substances. So we're going to look at a couple examples here. So if we had the specified amount of all ingredients listed, could we make 4 dozen cookies? So all of these ingredients that we have here, this exact specified amount, could I get 4 dozen cookies out of this? Well, the answer is no, because it tells you right here that it only makes 3 dozen. This is only enough to make 3 dozen. So all of those ingredients there would actually be limiting reactants. Let's look at another question. So what if we had 6 eggs, instead of my 2 eggs, I had 6 eggs, and then only twice as much of everything else. So twice as much of everything else. So I just doubled up this, but I tripled up the eggs. Could we make 9 dozen cookies? Well, the answer again is no. So I would have extra eggs left over. I'd have 2 extra eggs left over, but everything else would be limiting in that situation. So I can make 6 dozen cookies, but I couldn't make 9 dozen cookies. One more question. So what if we only had 1 egg? Could we make the 3 dozen cookies? Well, it says it takes 2 eggs to make 3 dozen cookies, so I don't think I'm going to be able to make those 3 dozen cookies. So the eggs would end up being my limiting reactant, and then everything else I would have extra. That would all be my excess reactants. All right, so let's look at another analogy. So I want to know what the limiting reactant is here with what I'm given. So I have 8 car bodies, just the car bodies, and then I have 48 tires. So those are my reactants. So the reaction is going to happen, and try to figure out what you're going to get for your products. And I want to know which one of these 2 is going to be my limiting reactant or my limiting factor in the end. So if we look at this, we see that each of these 8 cars needs to have 4 tires, because cars have 4 tires. So we put 4 tires on each of these cars. So I have my 8 cars here. And I had a few extra tires left over. So I have plus 16 tires. So which out of these 2 would have been my limiting reactant? Well, it would have been my car bodies. And then I would have had an excess reactant of tires. I had 16 extra ones. So let's take this all and put it into an actual chemistry problem. So with these, we're going to always still have chemical equations that we're going to be using. And the way that I have it set up here for you guys is I broke it down into kind of like baby steps here a little bit, step-by-step process that for you to kind of follow to get to your final answers here. You do have 3 questions. So the first one is asking, what is the limiting reactant? So it's giving you information. So you have 200 grams of this S8. So that's this one here. You have 200 grams of that, and it reacts with 100 grams of chlorine. So you have 100 grams of chlorine. So that's giving you information about each of your reactants. And the question wants to know which one of these 2 is the limiting reactant. So we're going to do some calculations with that. Then we're going to calculate the amount of excess reactant that we actually used, that actually did react. So we're going to figure out which one which one was my excess. We're going to figure out how much I actually used of that excess. And then from there, we're going to figure out how much excess was actually left over. All right, so let's take a deeper look at this. So we need to remember what each of these substances were, the mass amount, because we're going to be using those to start out the next part. So figuring out which is your limiting reactant. It tells you here, convert each into mass of product. So that means I'm converting this S8, and I have to go back and look at what was I given. I was given 200 grams of S8, and I'm going to convert that into mass of the product. So I'm converting it into mass of the product. So it'd be just like any of those other stoichiometry problems that I gave you. Maybe I would have given you 200 grams of S8, and I said, okay, how many grams of S2Cl2 do you have? And so you're just going to be doing a problem just like that. So I'm going to do that for S8, and I'm going to do the same thing for Cl2. So I start out with 100 grams of Cl2, and I'm still going to convert it over here into this S2Cl2. And I put a little note here, because you're going to come across some equations where you have more than one product. So you say you had this S2Cl2 plus something else, maybe H2O or whatever it is. So if you have two products, pick one of them to convert to. Stick with that one for both of your equations, because you're going to see that you're going to be doing two equations here. I have to convert this S8 into mass of a product, and then I have to convert this Cl2 into mass of the product. So pick the exact same product for both of those math problems that you're going to be doing. And then once you do your two math problems, then we look at the final result, and the one with the smaller mass is my limiting reactant. So here's what it's going to look like. So I started out with my 200 grams of S8, and if you notice, we have already done these types of problems. So this is nothing new to you. So I have to figure out my molar mass of this S8 because I started out with mass here. I want to get rid of mass, convert to moles. Okay, so remember when we do a mole to mass ratio, the mole number is always 1. I have to calculate my molar mass, and I do that by looking at the periodic table. So I go and find sulfur, get the mass off the periodic table, multiply that by 8, and that's how I got this 256.56. Okay, so grams end up canceling each other out. I'm now converted to moles. Now, since I'm in moles, remember I can go from moles of one substance to moles of my other substance. And remember, I said I wanted to pick a product. In this situation, we only have one product. But pick a product, stick with that product. So we're going to convert to this S2Cl2. So these numbers here for my moles come from my equation up here at the top. So I put my 1 and my 4 in there. So that converts me to moles of my other substance, moles of S8 over here, cancel out. And then now I can go from moles of my S2Cl2 to grams of it. And again, I have to get that off the periodic table, doing some little calculations. Okay, so I do that exact same setup for chlorine. Start out with what I gave you. So the 100 grams of chlorine that was given in the problem. Again, you got to get your molar mass here. So get your molar mass and convert it to moles. Then use your coefficients up here at the top to plug in the numbers here for your moles, and then convert to mass of, look at this, it's the same product as it was over here. That's what I was talking about right here. If you have, make sure you stick with the same product for each of them. All right, so now we're looking at our answers. And I said the one with the smaller mass is your limiting reactant. So I come down here and I look and I see I have 190.5 grams of S2Cl2. That's my smaller mass. So that means that my limiting reactant is chlorine. All right, so then we go to the second question, and it says calculate the amount of excess reactant that actually did react. So how much was actually used? So you're going to start with your limiting reactant's original mass. So the limiting reactant was chlorine. So you're going to start with that, and that was 100 grams. And you're going to convert the grams, convert to grams of the other reactant. So we're going to convert to grams of S8 now. So same setups as we had before, going from mass to mass. So start out with that 100 grams, got my 70.9 by looking at the periodic table, convert it to moles, do my mole ratio to convert to the other substance, and then again, get the mass of that other substance. So we end up with 90.47, and this is the amount of S8 that was used. I put consumed, used, needed, because you might hear any of these terms when you're doing this. Okay, so this is what we used in the reaction. Okay, so we didn't use all of it because we started out with 200 grams of the S8. All right, so that's for the second part. Now we get to the third part. It says find the mass of the excess reactant that remains. So how much is actually left over after the reaction is complete? So we go and we subtract our calculated answer of your excess reactant from the original amount given. So the original amount given was 200 grams of S8, and we just calculated 90.47 grams of S8. So we subtract those two, and you get the 109.5 grams of S8 left over. So that is your excess reactant that you have. Okay, so then that's all you're doing. So go ahead and try this practice problem and go through each of those steps and see how you do. Go ahead and pause the video. Okay, so first question was, what's a limiting reactant? So here are your answers for this. Again, remember, you are converting both of your reactants to the exact same product for this. You only had one product to choose from in this situation again. And to figure out which one's your limiting reactant, you look at your answers here. The one with the smaller mass tells you which one was your limiting reactant. So it's chlorine here again. Okay, so now in my next problem, I'm going to start out with the 35.0 grams of chlorine, and I'm going to convert that to mass of my aluminum. So go ahead and do that, and this is what you get. Okay, remember we had 3 sig figs, so we need 3 sig figs for my answer. Okay, and then to get your excess reactant, you take your 10 grams of what you started out with, subtract it from what you just calculated, you end up with 1.12 grams of aluminum as your excess. All right, you guys have one more practice problem, so go ahead and pause the video and try this one. Okay, welcome back, and let's check your answers. So which one's your limiting reactant? So here are our answers. And once again, our smaller mass here was the chlorine. So chlorine was our limiting reactant. Make sure you're using your correct number of sig figs for your answers. And next question was how much excess reactant you actually did react with the limiting reactant. So you would have started with chlorine's original mass, convert it to your other reactant, which was sodium, and you get 36.3 grams of sodium here. And then we're going to be using that number for our next one. So what is the mass of the excess reactant that's remaining? So you take your original amount, 85.0 grams of sodium, subtract it from that 36 you just calculated, and you get 48.7 grams of Na that is in excess. All right, guys, that's all we have here for limiting reactants. I will see you guys in class. Thanks. Bye.